To start this tutorial, download the 3DM file with the reference curve. You can find it in the video description and in our documentation. Once we have the curve, we will see that it is an irregular curve that almost passes through the center of the axis. To begin, select the curve. Go to the Curve tab and use the Offset command. Change the distance to 0.4. Then switch to Both Sides and set Cap to Round. Press Enter to confirm. Select the offset and move it to the same layer as our reference curve. You can hide or delete the provided curve. We will no longer need it for this model. Now, let's restore the 4 viewports. From the Shanks tab, create a classic ring. Then, click on Edit. Adjust the viewports to see the model properly. The first thing we will do is activate the lower profile. Then, we will change the profile of both curves. In the Assets section, select the curve that most closely matches the one shown in the video, straight at the bottom and rounded at the top. Also, change the lower profile curve to one identical to the upper one. Now, let's adjust the parameters of the upper profile. Set the width to 12 mm and the height to 5 mm. To reduce the weight of the model, change the type to Thickness. Then, adjust the thickness value to 1.4 to create a straight edge. For the second profile, the lower one, only increase the comfort height to 0.5 mm. Once the parameters are adjusted, click on Confirm. Now, select the curve. Using the gumball, extrude it so that it completely overlaps the ring. Next, go to the Solid tab. Use the Boolean difference command. Select the ring and press Enter. Then select the created solid and press Enter. Now our ring structure is almost complete. To continue, we will create several reference curves. Hide the curve and go to the Curve tab. Click on the Offset on Surface command. This will create offsets from the edges of our ring. Select the first edge. Make sure to choose the correct one, pointing toward the top of the solid. If you notice that it points outward once selected, click Flip to change the direction. Now type 0.7 and press Enter. We will repeat this process for all the edges of the model. To repeat the last command, simply left-click. Remember to select the correct direction and flip it after selecting the edge. Repeat this process with all the edges. Now, we will use the Blend command to create a smooth connection between the two lateral offsets. Select the command and then the two curves. Press Enter. In the Settings window, flip both point 1 and point 2. However, we will adjust their positions, so we may need to flip them again. Click on the higher point and align it with the other. Use the right view to adjust more precisely. We need both points to be at the same height. To see this better, activate wireframe mode. Adjust the points to a height of 2 units above the axis. Use the grid as a reference. To move them, click on a point and position it. Then click again to set it in place. Take your time to adjust the curves. It may be challenging at first. We can also adjust the curvature using the lower white points. Make the curve symmetrical, just over 2 grid squares from the axis. Once satisfied, click OK. Since we cannot see our curve, temporarily hide the ring. To hide the ring, select it and type Hide in the command bar. Using the gumball, move the curve to make it visible. Restore the ring. It's important to move it along the X-axis only. Now, from the Curve tab, click on the Project command. From the right view, select the curve, press Enter, then click on the ring. You will see that the curve has been projected onto the solid. We can delete the inner curves, as we won't need them. An important step is to check that all curves intersect. To do this, select the curves. Instead of selecting them one by one, right-click on the layer color. Then type Intersect in the command bar and press Enter. You will see points appear at the intersections. However, one is missing, meaning it does not intersect. It is crucial to fix this. From the perspective view, select the inner curve. Then, select the last control point. With O-snap activated, move the point onto the curve we want to intersect with. When end knot appears, click. Check the intersection again. Now we see the intersection point has been created. To continue, go to the Solid tab. Use the Push and Pull command. Select one side and press Enter. Then move the cursor inward. Type 0.4 and press Enter. Now do the same for the other side. As we see, on one side, the Boolean operation did not apply. But that's okay. The solid has been created. Hide the ring and we can see it. Perform another push and pull, but this time, move it upward by 0.2 millimeters. Restore the ring and perform the Boolean operation. Select the ring, then the solid. Now, our base is complete. Hide the curves to clean up the viewport. We have just finished our structure, and now we need to add our gems. Now, we will extract the surfaces where we will add the gems. In the Solid tab, use the Extract Face command. Select the two inner surfaces and press Enter. Now, we can temporarily hide the ring. We will now start creating our pavé. In the Diamonds tab, use the Automatic Pavé command. Select the first surface and add it to the selector. We will add different gem sizes, 0.8, 0.9, 1, 1.1, 1.2, and 1.3 millimeters. Then, use the pavé from point option. Now select a point as shown in the video. Adjust the pavé direction toward the center. Right-click to start the calculation. You will see the gems automatically arranged from largest to smallest until they are correctly placed. We will speed up the video while all the gems are being computed. We can see in the command panel, under the info section, how the number of gems is increasing. Once the computation is complete, add more gems if necessary. You can stop at any time by clicking the Stop button. You can add or move gems whenever needed. Now, fill in some empty areas, select the size, and add the gem. It may appear in red, but we will recalculate it later. Press Compute until all gems are correctly positioned. Display the gems for final adjustments. Remember that you can move, add, and resize any gem at any time and recalculate to reposition them. You can also lock gems if you believe their position is perfect. When you recalculate, they will remain unaffected while the rest adapt to them. When everything is to your liking, deactivate the gems and go to the Prongs tab to add them. Adjust the parameters. Diameter, 0.6 millimeters. Over girdle, 0.3 millimeters. Under girdle, 0.4 millimeters. Extension for manufacturing, 0.3 millimeters. Then press Automatic. Wait for the prongs to compute. This may take a few seconds, depending on the number of gems. Most prongs are automatically added. Now we can manually adjust some to refine the edges. Use different sizes depending on the available space. Ensure no empty metal areas are left and that all gems are secured. I will speed up the process, but take your time to perfect it. It is important not to move the gems at this stage. Since the prongs are linked to them, moving them would require redoing the prongs. Once finished, accept the command. Now, our pavé is complete, except for the other side, where we will follow the same process. This step is crucial. Hide the completed side and only display the side that still needs work. The visible gems will be detected by the pavé command, so it's important to hide those we don't want to interact with. Reactivate the pavé command, add the sizes, and select pavé from point. Select a point just like before and compute. Since the process is the same, take your time. Remember that you can interact with the gems to position, scale, and lock them. Once you're satisfied, add the prongs automatically and then fill in any necessary gaps with different sizes. After that, reveal the side we previously hid. You can pause the video and follow the process at your own pace. Once both sides are complete, press play again to finalize our model. Now that both sides are complete, display the ring. Select the gems and add the cutters. Change the height drill to 300 to ensure they fully cut through the solid. Accept. All our gems already have their cutters. Now we just need to cut the metal. Now, in the Solid tab, perform the Boolean difference operation between the ring and the cutters. Now we can see the inner holes created, with perfect spacing for the gems. Now, to get the best out of our model, create a beautiful render. If you need help with rendering, check out our free courses on rendering in Cycles and Keyshot. I'll leave an example render of this model. Feel free to share your results with us.